A cubic block of wood of side length L floats in water with the top face of the block horizontal and above the surface. The block is displaced downwards by a small distance L/10 without becoming fully submerged and then released. The density of the wood is 0.8 grams per centimetre cubed and the density of water is 1 gram per centimetre cubed. What is the initial acceleration of the block after it is released? So we notice that it's floating initially, which means that it is in equilibrium. So that means the block, in terms of the weight going down, which is 0.8 times its volume times g, which is 10. And in terms of up thrust, this will be 1, the density of water, times the volume submerged, I'll call that v dash, and then times 10. These must be equal. So the 10s cancel out, and we know that v dash must equal 0.8 v. So which is 8 over 10 v. Now it's submerged by a small distance L/10, so this is extra. So what that means is that most of it will now be submerged. So that's 9 over 10 of L, or the volume, because the cross-section area is the same, but the length submerged is a fraction of the total length, so the volume will be that same fraction submerged as a fraction of the total volume. So what we have is that the weight is still 0.8 times v times 10. So that is going to be 8v. And then we have up thrust is equal to, well, 1 times the volume submerged, which will be 9 over 10v. And then times 10 for g. This will equal 9v. Notice again, I'm not really working out the volume, even though I know it's L cubed. It's better to just use a simple letter of v. And then we want the initial acceleration. So we know we want the net force divided by the mass. So this will be 9 take away 8, which is just v, divided by, what's the mass? It's the density, which is 0.8 times volume. So we didn't actually need to know anything about the volume, just the scales and proportionality here. So this is 1 over 0.8, which is 1 over 4/5, which is 5 over 4. So the answer is C, 1.25 meters per second squared. Hopefully that made sense, but if you have any questions, please do let me know. The key features here are to work out that, well, firstly, find out that it's in equilibrium first. That's why they mentioned floating. And then you want to be able to work out the net force and then divide that by the mass to get the initial acceleration. So it's useful to work backwards. In order to get the acceleration, I need to know the force and mass. In order to know the force, I need to work out the weight and up thrust. And then you can piece it together.